Okay, so here, let me fix this. This isn't the best handwriting, but it's just real quick. 3 fundamental quantities of mechanics. Yeah, that's what that says. Mechanics, just the study of motion, not electricity, magnetism, not waves, not like modern, like quantum or nuclear. Just your basic how stuff moves. Most of you already know that. So it's a review for most of Physics C, but make sure everyone in your group understands that y'all are on the same page. Juniors are good with it. New people are good with it. You remember it, how it relates to your projects, that kind of thing. All right, so first of all, let's go with there's 3 things. And I know John and Ashley and all of them are doing this for their project. Let's see if I can get this to work right this time. First one. The first one is mass. That says mass. All right, its symbol is a cursive M. All right, the SI unit for mass is, sorry about that, is going to be a kilogram, kg. I don't write that out. Remember with physics, you're on the MKS because we're dealing with bigger stuff, system, instead of the CGS from chem. It is meters, kilograms, and seconds for your 3 fundamentals. All right, dimensional analysis. I kind of think told some of you about this last year, but if not, it's just basically you use a capital letter to like analyze it without having to think about the symbols meaning something. It kind of takes you out of the whole like, oh, that, no, that equation thing. So for your dimensional analysis, it is capital M. And I'll kind of show you some stuff on that. All right, so let me do a different color here, blue. All right, so for anyway, so let's go mass, let's go length for the next thing. Okay, maybe. And as you know, this can also be displacement. Distance, kind of. Distance being magnitude of displacement. Height, width, depth. I've said length. Separation. Remember from the equation sheet, they called it separation. Radius, you know, anything that you would measure. I'm just going to skip right over here in meters, which is not cursive. Oh my God, the symbols for these. Delta X. S with the arrow, which maybe we'll write on here, maybe it won't. S with the arrow, cursive L, just delta Y, R, lots of different things. Basically, that one in context, if it's measured in meters, it's fundamental quantity of length, and that is going to be a capital L. All right, and then let me find one more color. Actually, let's go with the black pen. Okay, and the last one's the easy one. Saved it for last. And it is time. Okay, that one's easy. This actually is 2. I didn't really cover this last year as much, but lowercase t for time interval, which you set, and then capital T for time period, which is set by like a revolution or an event, class period, whatever. All right, and this is measured in seconds, easy enough. Lowercase s, print s, different than this one, which, oh man, I erased it. For displacement, should have a, still learning to use this, apologies. Okay, we should have the arrow on top, y'all should know that. Anyway, that should, seriously. Okay, whatever, that's supposed to have an arrow. Okay, and so this would be capital T. This is just kind of an in context thing. If you're using this MLT way to like break stuff down, then it's not time period. Let me show you what I mean. Okay, to do this, I am going to tell you the story of physics, but in dimensional analysis form. The reason why this is so useful to have this be this like general capital mass M, length L, and time T is because it doesn't matter what system of measurement you're using. I mean, right now y'all are kind of okay, the AP test uses SI units, like what I have over here. But I mean, you really could make measurements in anything. And I think y'all kind of, some of you saw last year, that's more useful sometimes just to do it whatever you happen to have available to measure with or whatever is given. So, but AP test will be nice and just do SI units. Anyway, let's tell the story of physics. So we have change in position. Or first of all, you start off with like position. You're just standing there. Then you change where you stand. Okay, well that's displacement. SI units are meters, but displacement would be a unit of length. So we start off with just L. Okay, so here I'll just arrow. And then we go here. Okay, so, and I'll kind of get you started on it. Tomorrow I might do like, I don't know, I might have y'all kind of show me how all this works together. Okay, so let's put that over change in position over change in time, which would be velocity. All right, I'm being all good and putting the arrow. Okay, so that would just be dimensional length over time, dimensional analysis time. See, so this wouldn't matter if it was in feet per hour, miles per hour, or meters per second. All right, well, I think a lot of you know the next step would be your change in velocity over, whatever, over change in time. And that equals, everything is so annoying, equals acceleration. Okay, so let's look at what that is. Well, we have, I'm just going to come over here, I'll probably erase this. You got your velocity from up here. I'm going to multiply. By the way, that means divide. If you weren't in my class last year, that means multiply. Lazy man's parentheses. Okay, we're just going to divide that by time. Again, so that would give you dimensional length over, hey, time times time is time squared. I think a lot of you at this point are probably seeing where I'm going with this, but I'm going to go a few steps further. And this way you can also just analyze your work. I'll show you that in just a second, how quickly it is to see if you have the right answer on something. It's like that kind of checking for units, but like way faster. Okay, so then let's go to, let's just go to mass. Let's just kind of inject mass here. Let's just do mass, because that's one of your fundamental ones. We hadn't used it yet, might as well. Mass. Now let's just times acceleration. And as you know, that is force or net force. I'm just going to put force. It's technically, yes, I know the law says it's net force, but let's just do force. Also vector quantity. Let's see, let me attempt to write with my little pen thing here. Okay, and hey, look, that's just mass times your acceleration over here. So that would just be mL over t squared. All right, let me show you how this is useful. Switch colors here real quick. Let's say that, let's just look at SI units with this. This is like you can do your unit conversions really quickly. Oh, hey, look, length, meters, meters per second, meters per second squared. Oh, kilogram, meters over second squared, aka a Newton. All right, well here, how about if we're doing feet? Let's go feet. Feet per second. Feet per second squared. Yeah, I know I'm using feet. All right, and then this would be, I don't know the abbreviation for this. It's kind of like what a pound is. It's a slug. Yeah, slug. Okay, let me get this right. Slug. I've forgotten how to do this. Slug foot. You got to have all kinds of parentheses. And oh yeah, I should have put like a little dot. I hate this system. Slug foot over seconds squared. And I think that works out to be a pound. I'd have to look that one up. It might be, I think it is seconds. But it's something called a slug. You don't want to deal with that, but I'm just showing you, like, I mean, you can make up your own system. That just works out really nicely. Okay, so let's say this is good for like balancing equations. Let's say, okay, something really simple, like, I'll come down here. Okay, let's say that you have like work equals force dot displacement, right? Okay, so don't worry about the dot, the cosine theta. So let's see if that balances out. Well, you'd have force, that would be ml over t squared, right, times displacement, which is L. Okay, that's for your force. So that would actually, let me just make this a little bit easier here. That would just be ml, or mass length squared, times time squared. Well, hey, guess what? That's all work is. Because we can look at the units on that if you want. Because you know, mass length over time squared is a Newton. A Newton times another unit of length, if we're using SI, would be meters. Newton meter, need money to buy joules. It's a joule, it's what work's measured in. All right, you can also prove that things are false this way. Let's say if I said, let me do one I know is wrong. Okay, let's say that I said acceleration. I somehow did some kind of, God knows what kind of math, and I said acceleration equals velocity times time. Let's see if that would work out. Well, we know that, and this one's a little bit kind of simpler. Where's my pencil? Okay, so acceleration, let's look up there. It's up here, is length over time squared. Okay, let's see if this equals. I'm going to assume it does for right now. Okay, length over time, right, for velocity up here. Okay, and let's multiply that times time. Oh, hey, look, that is no good because this is just length, so this doesn't equal. So I would need to go back and be like, oh, I have messed something up. Let me redo this problem. All right, just kind of some examples on that. It helps, this just helps kind of clarify things when they get like a little murky, especially with different units of measurement. And it'll help you with conversions too. All right.